The paper delves into the broader utilization of data augmentation methods based on masked language models, MLM, in natural language processing. It begins by discussing the prominence of pre-trained language models such as BERT, RoBERTa, XLNet, T5, and BART, which have revolutionized the field of NLP. These models rely on transformer-based architectures and unsupervised learning, trained on large text corpora to learn useful representations of language. They can then be fine-tuned on specific tasks with smaller amounts of task-specific data. The authors introduce the concept of masked language modeling, a key feature of BERT and similar models, where some percentage of the input data is masked during training, and the model is trained to predict these masked words based on the context provided by the unmasked words. This approach enables the model to learn a deep, bidirectional representation of the sentence, leading to significant improvements on a wide range of NLP tasks. The paper also explores the role of masked language modeling in pre-trained language models, highlighting its importance in enhancing model performance across various NLP tasks. Data augmentation is another crucial technique discussed, enhancing the quantity and quality of training data through methods such as paraphrasing, noising, and sampling. The success of pre-trained language models in recent years has led to their utilization in generating augmented data, employing techniques like masked language models, GPT-2, and BERT to create both corruption and reconstruction models, resulting in high-quality augmented data. Unsupervised methods, such as mix-up, leverage in-labeled data to generate additional training examples without requiring explicit annotations. Lastly, machine translation, particularly back translation, is explored as a method for data augmentation, offering a natural way to paraphrase text. These techniques collectively demonstrate the power of data augmentation in enhancing the performance and robustness of language models. The paper discusses the role of data augmentation in enhancing the performance of pre-trained language models, particularly focusing on masking-based data generation. It highlights how masking-based data augmentation can be applied to various pre-trained language models, including those that go beyond the traditional masked language modeling, such as T5 and GPT. The authors emphasize the importance of leveraging large language models like GPT-3 family models for scaling instruction fine-tuned language models. They also explore the use of unsupervised data augmentation methods for semi-supervised named entity recognition and natural language understanding tasks. The paper delves into emerging data augmentation techniques, including those that utilize adversarial training to enhance model robustness and performance. It mentions how these methods can expose models to challenging and diverse examples, mimicking real-world linguistic variations and potential attacks. The authors also discuss the effectiveness of masking-based data augmentation in improving the performance of pre-trained language models, referencing several studies that have utilized this technique to achieve state-of-the-art results in various NLP tasks.